There it is. Saving for later. Tasty goodness.
Well, Anna, everyone. Thanks for joining us this morning. I'm actually, oh yeah, the numbers are still rising, so I'll just give us another couple of minutes and then we'll get underway. $99, $100.
Oh, yay. Bingo. Got to provide good entertainment.
Fantastic. They do look like they're slowing down though, so we'll get underway. So morning everyone, or just gone midday. My name's Ella Lawton and I'll be MC for this session. So just thank you so much to Meg and Jonathan for joining us today to provide some background on your catchment scale map analysis to identify and prioritise nature-based solutions. This program is sponsored and brought to you by Regional Council's River Managers SIG Special Interest and Te Uru Kahika. At the end of the seminar today, it is being recorded and the recording will go on the Resilient Rivers website and it will be under the heading Nature-Based Solutions in the recordings there. There will be time to ask questions at the end of the webinar. Please put your questions in the Q&A box. Feel free to do that during the presentation and we won't take questions until the end. And feel free to upvote. That's really helpful for me to prioritise the questions at the end. If you can give me a heads up on which ones you also like and as well as potentially adding your own. And feel free to send emojis Meg and Jonathan's way throughout the presentation because that's always a good, lift and there you go. Love hearts coming in.
Yeah.
Awesome. So thank you so much, everyone. And I'll pass it over to Meg and Jonathan to introduce themselves.
Awesome. Thanks very much, Ella. Appreciate the introduction. And yeah, hello, kia ora, everyone. I'll introduce myself first. So yeah, my name's Meg Tyler. I work for Northland Regional Council. I'm a rivers project manager, so I manage the flood infrastructure projects for the regional council up here. I've been in the job for 3.5 years now. And yeah, so I live in Waipapa, Kerikeri in the Bay of Islands, work out of Waipapa as well. And my background, I'm a biologist by degree, so terrestrial ecology with civil engineering experience, a lot of geotech and kind of geography work as well. And then obviously some management stuff as well. So my real interest lies around, I guess, landscapes and how water moves throughout a landscape and kind of how humans live within that landscape and that kind of whole picture. So this is really a dream job and a very fun project that's come out of it as well. So that's me.
Okay, kia ora koutou. I'm Jonathan Cousins. I'm a senior hydrological engineer at Vision Consulting Engineer. I'm also based up here in Kerikeri in the Bay of Islands. Academically, I've got a master's degree in civil and structural engineering, and I've about 15 years technical consultancy experience. That's gained predominantly in the UK, but I've worked for a few years in Australia, and also now I've got a year under my belt in New Zealand, having emigrated here last year with my partner and dog. In those 15 years, I spent a good portion of the first third of it working in kind of civil infrastructure and drainage design, and then kind of moving into supporting big renewable schemes in the UK. So that was really, it's about that environmental and hydrological advisory roles and doing the technical assessments and being on site whilst construction's happening, being on the ground and giving that advice as things occur on site. A big part of my work has been in peatland restoration. So I've been fortunate enough to have been to travel all throughout the UK and the more remote areas of Scotland, and being part of teams of ecologists and ornithologists, and really getting a solid kind of broad and diverse working background. The last 5 years were more into kind of water resource management and hydroecology. So lots of like habitat modeling, usually from a hydraulic perspective. And again, wetland, peatland and river restoration projects. Also in the UK, we do actually suffer from quite severe droughts in the summer. So lots of emergency response planning and kind of investigations around those. So kept very busy some years. Over in New Zealand, I've kind of fallen into this role and this project. So yeah, this has been my big project since I've been here. And Meg's really cracked the whip and kept me working hard and
squeezing you for all your work.
Yeah, essentially. Outside of work, I'm big into the outdoors and kind of hiking and foraging and things that really get me down into the muck. So
you get to see some drone videos that you've taken later on as well.
Yeah, so it's really into nature and hydrology and getting out and about and sharing that with people as well. So hopefully that will show through this presentation, and and we'll go from there.
Lovely.
So back to
all
Meg.
right, shall we crack into it then? So we'll go on to the first slide here. So I'll just give a bit of context as to the catchment that we're working in for this project. So the catchment that we're working in for the nature-based solutions is called the Taumārere Hydrological Catchment. It means you can see the catchment outline on the photo on the left there. So all of the water that kind of falls within that area flows out the Taumarere Inlet, which is just downstream of Kawakawa. If anybody's been to Kawakawa, they have the world famous toilets, Huntawasa. So we've got two of our main townships, Morewa and Kawakawa, and the State Highway 1 that runs through that catchment as well. We have referred to it in past as the Upper Kawakawa Catchment or the Kawakawa Catchment because it's the main township, but we also refer to it as the Taumārere Hydrological Catchment, so interchangeable there. The catchment as a whole is about 490 kilometers squared. So for Northland, that's quite a big catchment. I think it's in our top 3 catchments in terms of size. The kind of typical terrain of the catchment is steep hills and flat, narrow valleys. So that means we get quite a bit of quick runoff from the hills, and then it likes to sit around in our valleys for a long time. And yeah, the land use for the catchment, predominantly kind of exotic forest. So we've got a lot of forestry trusts out there, so typically pine forestry, and then a lot of agricultural land as well, so kind of beef and sheep. And then we still have pockets of native forest present kind of on the eastern side of the catchment you can see there, and then the far south and west as well. So a good mix. Yeah. So we have existing flood infrastructure in the catchment in the kind of downstream areas, what we'd consider the downstream areas. So in the last 3 years that I've worked for council, we've completed kind of these hard infrastructure projects. So one in Morewa, Oteria, a big spillway. It was a $8 million project funded by the Shovel Ready MBIE. And that was a big spillway and a new bridge protecting the township of Morewa. And then also Kawakawa, we built a deflection bank there last summer. And so that was protecting the shops from one of the streams that comes in around the back there. So we have an existing kind of flood liaison committee that we work out of this catchment. So we collect a targeted rate within that catchment, and we use that money plus other funding sources to invest in infrastructure projects here. That catchment group has been around since I think 2016, so before my time in council. But it's a really great group. A lot of these projects have come out of that group, and so it was through that group that we discussed what we could do in the upper catchment here. So that conversation was starting around kind of 2 or 3 years ago, is okay, we've built these kind of hard infrastructure bits downstream. Let's have a look at the wider catchment and the upper catchment and see what we can help with up there. And really the main issue that the residents have in the upper catchment, which is a bit more rural, is the roads going underwater. So we get quite a few roads that go underwater in not very big rain events, and they can stay closed for about 3 to 4 days at a time. And they'll go underwater, you know, kind of anywhere between 5 to 8 times a year. So really regular kind of events, which obviously results in a lot of community isolation and disruption to emergency services and just the lives of those residents. So thankfully, the Ministry for the Environment, Nature-Based Solutions feasibility funding came available kind of at the same time we were having those conversations with the residents. So we paired them up together and said, all right, can we, is it feasible to, you know, reduce the flood impact over these roads in the upper catchment using nature-based solutions interventions? Hence the birth of this project. And then we've also got a good little clip in there of one of the RNZ articles on living in the realities of living in Northland's most flood-prone town, Morua. So this next map just shows so we did some quite extensive community consultation. As I mentioned, we've got that catchment group, so we're quite connected with the community here already. So this is a map that was produced from kind of the first initial consultations we had out of 4 marae in the upper catchment. And yeah, those consultations were kind of talking to the community about what the project was, what nature-based solutions were kind of compared to hard engineering. And then the information we were trying to get as well from the residents is which are the roads, like what are the roads that are most impactful when it comes to a flood, so which ones close first. So we have a region-wide flood model for this catchment already that shows the 10, 50 and 100-year flood extents and levels. So we had a pretty good idea of which roads kind of were the problem roads, but we really needed that validation from the community to make sure that we were on the right track. So this map, all of those yellow stars are showing from the community which roads were the real kind of pain in the bum roads for the community. And then obviously there's 14 locations. So we thought, okay, we need to narrow this down to maybe 4 locations. So we spoke with the bus driver, Perry Clark, who's based in Kawakawa, and he does the full route. And so he narrowed down kind of 4 of these locations as the worst locations. So the ones that will cut the bus off first from being able to go out and either drop off the kids or pick them up in the morning. So just looking at the map, location number 3, kind of to the left, on the left side of the screen, we'll be looking at over the next few slides. It's a really bad road flooding area, and then we've got one other location that we'll look at as a potential case study site later on in the presentation. Cool. All right, and so we've got this lovely drone video. There's no sound, just video, but you can see the road that the car is driving on through the valley there. It was just a really great video. Jonathan took it after a not huge rain event at the end of April or May this year. And we had a saturated catchment. I think we had about 20 mils of rain over a 24-hour period. So again, nothing to write home about most of the time. But you can see how disruptive this is to the communities there. So you can also see the kind of steep hillsides where we get that runoff, and then, yeah, these flat, narrow valleys. And the, what do we call it, legacy infrastructure that we're dealing with in terms of the roads. So some people might look at this and say, oh, well, why don't you shift the road, you know, to the side of the valley? And yes, that's an option, but we would consider that a kind of hard engineering solution. And this is looking at nature-based solutions. So can we use nature-based solutions to reduce this flood risk that we can see on the screen there? Cool. So this next slide is just taken from our rain gauge in the upper catchment. So Waiharakiki. The red arrow shows the event that was happening when Jonathan took the drone video that we just saw. So as you can see, it's what we're just trying to show here is that, yeah, we had a wet catchment, we had a saturated catchment. Again, we got, I think it was 20 mils over the last 24 hours, and that resulted in road closures for the residents. And this is just looking over the last year. So these kind of events aren't uncommon. They happen really regularly. And so they are really disruptive for this community or these communities. This next map is looking at that same location. So you can see the red zone, Matawai Meramaku Road, kind of at the top of the screen there. That's again looking at where the drone shot was taken. And this is really great. It's a topographical sink map. So it shows where water will sit on the earth, not taking into account kind of conveyance of the water, but it really shows, yeah, where the water is sitting on the ground. And so something that was really powerful about this map was looking at these two catchments kind of to the south and to the west that are the two contributing catchments upstream of that road location. So you can see the kind of old meandering natural river channels in both of those catchments, and then kind of bigger wetland storage areas upstream of those as well. And then what the map also shows is the man-made drains that have been cut through those valleys, just for land drainage, obviously for agricultural use. So once we kind of were looking at these maps, it really did confirm, I guess, that there is a potential for us to look at nature-based solutions, interventions in this catchment, and for it to have that positive impact downstream. Yeah, it was a really good
one of the earlier part of this project was the hydraulic modeling and looking at very specific, quite discrete areas. So thinking about working within 100 or 200 meters of the flooding event, the location of flooding, and it was soon apparent that the magnitude of the floods just meant that dealing with it locally just wouldn't have the impact of thinking about storage and slowing the flow upstream. So that's where this nature-based solutions project at a catchment scale really kicked off, and that was only in January. So
yeah, January last year. Yeah, this year.
Yeah.
Oh, gosh, time. Yeah.
Yeah. Onwards.
Yeah, cool. So these photos are again taken on that same day or roughly around the same time, again with the drone, but yeah, looking upstream at those contributing catchments. And again, you can see those meandering natural channels, but then also the straight cut drains through there. So there's definitely an opportunity for intervention in these areas. And then we've also got a lot of the bottom right photo showing the plant, the exotic forestry on the side here. And yeah, this is really kind of what the residents were telling us in the community consultation as well. A lot of the corridor was around, people being able to kind of see the degradation happen or the modification happen within their lifetimes. There was a lot of stories around, communities living in these locations and, experiencing them as pristine kind of environments that they could utilize and be engaged with. And then now within the lifetime, seeing them kind of modified and seeing those impacts downstream. Yeah.
Okay. So we've got a good sense of what the issues are and what's happening within the catchment. So now it's really the question of will nature-based solutions actually help, and what are they? So we have taken what we learned in the community engagement and through the modeling project and thought about which nature-based solutions would really be useful in the catchment. So this slide is just showing a photo of the ones that we've selected. We chose 8. And
because we like a challenge.
Yeah, because we like a challenge. There is a 9th, which is more catchment management, but we haven't included this here. So just running through them quickly. The next slides do show them in action in a little bit more detail. So we've got also just working from upstream to downstream as you might implement them. So native forest and vegetation. So that's your planting up of the hill slopes. Then we've got the steep slope control, erosion control, which is not just planting, although that's predominantly what it's known for. You can have more hard engineered and more involved slope control. The next one would be leaky barriers, really aimed at slowing the flow. We'll come to it a little bit later, but then silt traps, which is farm intervention, really. It's something that's very well known in the catchments. It's used throughout. Again, it's just looking at pockets of storage and intercepting silty runoff. Then we've got riparian planting. As the name suggests, it's along riparian corridors, along watercourses. It's quite often where the cows are getting into, or the cattle's trampling the banks. Moving further downstream, where you've got the floodplains that allow it, and where there's an appetite for restoration, we may want to create more storage and allow those floodplains to actually function. So that's reconnecting watercourses laterally back to them. Then we've got wetland restoration, which, well, is essentially just pockets of wetland. Like what Meg was saying earlier with those topographical sinks, they're quite often going to be wet areas, and you'd kind of expect there to be some wetland features there, or whether they've been drained out.
Yeah, I think we've heard from a couple of farmers actually around these kind of areas as well on their farm, which maybe they've been trying to drain historically and have been kind of losing the battle. So that was definitely something that popped up in the consultation.
And then moving all the way down to the estuarine zone, we'd be thinking about this intertidal wetland restoration, and that's really become quite central to the work through the community engagement, because whitebait and anga are important in this catchment to the people here. So
absolutely. Yeah, I guess maybe just a comment on that as well. Quite a few of these nature-based solutions, farmers or landowners are they know about already. They're not kind of these big foreign concepts that you're coming in and asking them to understand. And especially with the steep slope erosion control, like Northland Regional Council at the moment have a hill country erosion program that they're working with farmers on. But then also things like the silt traps, when we go out and talk to landowners, everybody already has a good idea of what a silt trap is, and you just need somebody who's a skilled digger operator really to be able to install them. So not the most complicated of things.
Okay, so the next is a bit of an artistic mock-up of one of the upper catchments zones. I say artistic mock-up. It was frustrating. So if we look at the before shot in the top of the screen, you can see you've got some bare hills in the background. You've got some quite steep slopes that are barren of, don't have much vegetation. It's mostly grass. You've got number 3, which is your kind of catchment management issues. You've got quite often cattle are able to get into the watercourses. Then you've got number 4 in the top image this is. So you've got these straight ditches, which are just really keeping that what might be floodplain dry. It allows the farmer to maximize the productivity of the land. But what this can cause is down cutting of stream beds and a quick conveyance of the sediments that are maybe kind of mobilized from the hill slopes. Then we have, this is more of a implied number 5. So this is where you'd have some quick overland flow runoff coming down the hill, and it's going to hit that floodplain quite quickly, get into those ditches and be conveyed downstream. So number 6, you've got a pretty distinctive lack of riparian vegetation. So there's not much that's offering habitat within those ditches. Number 7, it's really just going on from number 4 and number 6, that you essentially just have a disconnected floodplain and wetland area. And so really the MBS that we've selected are looking at healing those in some way. So if you're looking at the after shot in number 1, we've got some native vegetation being planted up, hopefully to kind of connect up isolated pockets and create some habitat corridors. You've got your steep slope planting, which up here is predominantly willow. No, not willow, it's poplar. Yeah, so we've got that basically importing an exotic to fix a local native problem. And then we've got the catchment management issues. So this is really just fencing and better management of livestock. Then we've got the leaky barriers. So they're really aimed at reconnecting and lifting water back out of those ditches and onto the floodplains, and ideally into a restored area. So leaky barriers are a little bit of a, it's a, what would you say? It's a not well-known concept
it's not a well-known concept in New Zealand, I don't think. When I was like kind of researching it, I guess I've heard about it through in the UK. It's quite a common practice to use leaky barriers. It's, what do they call it? It's natural flood mitigation on farm, but in New Zealand I wasn't able to find very many well, any examples of leaky barriers in use. And I think a lot of the time the conversation is around pulling wood out of the streams and pulling wood out of those overland flow paths, rather than pinning wood into it.
Yeah.
So that might be a bit more of a difficult conversation.
Yeah, so I think it's just important to always bring it back to that.
Mm.
If you are restoring an area, then select your area carefully, because it will be getting wetter and more vegetated. Yeah, so that's bringing us into that riparian planting and the fencing. And then with these combined, you've got a nice fenced off wetland restored habitat. And a lot of these are, again, just looking at, in my mind, it's a transitional step. So we know that with the planting that eventually trees will be falling into that water and acting like replacing the function of a leaky barrier. So the leaky barrier is this interim step whilst the trees are growing, and it helps just to lift the bed up, lift the water out onto the floodplain. But again, it's just in the locations that you really want that to be happening. Yeah, so the after image is probably an idealized version of what would ever happen. And later on, we will look at a more of a practical application of this. Yeah, I think we'll move on to the intertidal.
Yep.
Yeah.
So yeah, this is quite a similar slide showing those intertidal zones that Jonathan was talking about. So this is really looking at enhancement of kind of inanga habitat areas. So inanga are quite selective about where they like to lay their eggs and where they choose their habitat. And this is kind of quite a typical look at what the lower part of the catchment in this catchment looks like. So yeah, loose and eroding banks, not a lot of vegetation, and not a lot of stock fencing from the riparian zones as well. Yeah, and then the aftershots showing a schematic of what the environment could look like, and also how it's just a little bit more inviting, I guess, for people to come and see and experience those kind of environments.
It was just the inanga a whitebait. I don't know if we said that, it's on the slide, but it's it's an important food source, and also very culturally significant in this region, and also it's potentially an economically viable revenue for the future if we are developing these habitats that would support it. So it's that thinking about the future, really, and what we can leave as a legacy more than anything.
For sure.
Yeah. Feeling it's me.
All right. This slide is a lovely little slide showing how we might encourage landowners to scope projects on their own land. So kind of through this feasibility study, one of the initial questions we asked was, how much land would we have to transition into nature-based solutions to get the same flood reduction benefit as you would get from maybe a hard engineering solution? And before trying to model that, the answer was kind of a lot. You'd have to do wide-scale land use transition to see those benefits, and I guess that makes sense. Yeah, with the flood reduction, but also with the co-benefits of it. So really, we thought, okay, what we're aiming for feasibility is wide-scale transition within this catchment and adoption of nature-based solutions. And we as council don't own any land in this catchment. It's all private land ownership. And so we went down the route of kind of looking at the process of how you facilitate landowners to be able to scope and apply for funding, and then actually implement their own projects on farm or on site, which a lot of farmers already do as well. So it's, yeah, how do we facilitate that transition? So we looked at kind of the workflow of what landowners would need to result in having a scoped project that at the end of the day they can start putting shovels in the ground and doing the work and actually implementing the nature-based solutions. So I came at it from kind of a project management perspective of engineering projects, flood projects, and saying, you know, what do we need for those, and so what do landowners need for their own. So if we just go through the steps on that, it's understanding the kind of risk areas on your property. So where are your high risk areas? Where are your low risk areas? Then choosing your interventions for those areas. So what different nature-based solutions might be appropriate for that risk area on farm. And then that allows you to see kind of the scale of change or the scale of what you would need to implement to see a benefit. And from there, we can start estimating costs of what it would cost for that implementation. And then we can look at funding options. So what are available for funding? And then also just providing the landowners with practical guidance around installation and defining aspirations. So that kind of ties into the funding options. We need to understand the aspirations of the landowners, and that can be multiple things in order to apply for the funding, but different funding grants are available depending on your aspiration as well. So it's quite an important step. And then also the monitoring as well. So how are you going to monitor the effects of the work that you're implementing on your land? And then pulling it all together, putting it into I didn't want to use the word, but a shovel-ready project. We love that. In order to, apply for that funding and then connect with the local capability and capacity in the catchment. So we're working really closely with Ngāti Hini, who are the main hapu in the iwi in the Taumarere catchment, and they have a lot of local capacity that they're building within their teams around wetland restoration, and now looking at kind of these other nature-based solutions options as well, and how you might upskill young people in the catchment to be able to carry out this work.
I think it's worth just mentioning it is quite a socially deprived area in some parts. So this potential for employment through nature-based solutions and restoration it's very appealing, and it's it's a big aspiration, and it's one that
definitely and there is a big aspiration to be working out in nature as well, out in the Taio. So
so we'll go on to trying to map the risk now. So mapping the riskscape. Before we really got stuck into the nature-based solutions and optioneering and looking for funds, we wanted to know what are the risks and what are we really dealing with. So we went down the kind of multi-criteria GIS analysis of the risks. We looked at 3 different types of risks and then a combined one. So it's basically multi-criteria analysis. We've been using the kind of metaphor of around a recipe. So we're taking a bit of each ingredient, adding them together in a specific way, and then we process it and we put it in the oven, and what comes out is hopefully something that represents the realistic risks on the ground. And what you do find is it can be quite an iterative process. There's lots of failed cakes along the way. But what we got to in the end is the kind of the outputs that we're seeing on the right-hand side here. So at the top, we've got the steep slope erosion. This is actually the site we'll look at later in a little bit more detail. So on the left-hand side, you can see it's quite a barren landscape in terms of vegetation. We have pockets of native vegetation that's hanging on in some of these fenced-off valleys, but generally it's actively eroding gully systems. So the right-hand side is really pinning that higher class risk, the class 4s, into those valleys. And this is going to help us just think about where we're going to implement work later on. The risk below is in-stream erosion. So this is looking at those hydraulic forces within the stream and thinking which ones are going to be the most erosive and where. So the example here is it's an overflow spillway, so it's connected up to the main channel during events like high flow events. So it means that the only flow it really receives is high energy flow, and this is the the mapping picks out those hot spots of erosion there, and it's also visible on the image, the aerial to the left, which is those brown landslips that we're seeing. And this is quite a large contributor of sediment into the downstream system, but it's only active for a few times a year. But the mapping picks it up as being quite a high risk. We'll move on to the next one. So the next one's looking at more water quality and specifically nutrients and pathogens. There are a few caveats with using this kind of approach when you don't have the water quality monitoring data for your catchment at the specific spots, and you also don't know point sources of pollutants or diffuse sources of pollutants. So this is really, I wouldn't say it's a proxy, but it's leaning more on the hydrological connectivity and those overland flow paths, and where water might move from a more high risk area and into the watercourses downstream. So in the example, I've tried to pick out the big fire alarms going off. You might hear that, sorry. So we've tried to pick out a legacy old slurry, like pig slurry pond. And what's that showing is that if that overtops, it's going to run down towards the north and into the watercourse. That would be a high-risk point source, but also of importance is what this map doesn't show is the groundwater connection in this, and that to the east in this shot is the stream and waterfalls, and the community have mentioned groundwater movement and bringing through some nasty pollutants. So this method, although good, does have limitations. So it's getting us a step closer to knowing where the higher risks are, but we do have to tread carefully with some of it. So I think even terming it risk is risky. And we landed on the term relative environmental risk, just because of the nature of how we've processed the data. And then the fourth risk, as we call it, is a combined and weighted risk. And that's looking at these, essentially stacking up those layers that we've just looked at and thinking about the hot spots and where we would be really wanting to focus our efforts. In the image, can't actually see it because it's under that. Oh, lost it. Yeah, so we're seeing those hot spots along watercourses, essentially, and on the steep slopes that are directly adjacent to those watercourses. And that's, yeah, it's quite common throughout the area. We're on a lot of like weathered volcanic soils. So when they're exposed to this type of concentrated flow, you will see that quite rapid erosion of channels. And what this has done, because we've done it at high resolution at full catchment, it's allowed us to look at sub-catchments within it and start thinking about prioritizing them. And this is really, it's where catchment managers would come in. So the next slides are just going to cover off that catchment prioritization. So this is for steep slope erosion, and just on the color scheme itself. So the darker colors, the blacks and the grays, they are more the lower risk catchments. But what that is really saying to us is that they are nice native bush, essentially. So they're places to protect and use as seed sources, and trying to connect into them and trying to not necessarily use the word neutralize some of those high risk zones in between them, but certainly think about connectivity of habitats. So what you're seeing here is quite typical. We've got those steeper catchments. They are quite heavily farmed or forested. So we have some real telling signs in the information there. Yeah, we'll move on to the next slide. So again, in-stream erosion. This is typically what we're seeing mostly here is that the more of the erosion. I mean, it's kind of common sense that when we've taken away the vegetation and we've concentrated it down into straight ditches and modified watercourses to convey water downstream quicker, then we're going to see these higher velocities in those channels. So this is looking at really where those big systems are the worst, and where we could focus on maybe a big river restoration or some more in like more work in the upper catchment to slow flows down through the catchment. We move on to nutrients and pathogens. Again, as expected, because we've used the data that we had available to basically estimate where we're likely to see pollutant sources in the landscape. We're seeing it a lot in those big agricultural zones where we do have those rolling hills, grass, just grass hills. We've got those straight ditches. So we're seeing a lot of this quick conveyance of nutrients. There's not too much storage happening upstream. Also, any urban centres, more notorious for contaminants entering the watercourse.
Self-explanatory.
Yeah. And then on to the combined risk. So again, we're seeing those similar themes, but it gives a little bit more emphasis of those bigger locations where we're seeing these big inputs of nutrients or sediment, or there's a lack of native plant cover or diversity there. And this is, I think, really useful for a catchment manager perspective, not just for knowing where we can start doing restoration and intervention, but also from a monitoring perspective. If we're looking up here around Maramaku or something, then we'd probably want to start thinking about water quality monitoring or flow monitoring downstream of this area, and then we'll be able to probably better track whether interventions are working on site, and also just targeting really
those highest
the higher risk catchments.
Yeah, for sure. Especially when we're in a catchment that is, it's quite large, like we were saying, 490 kilometers squared, and we do have quite a small population. I wish I had the population numbers, but I know 2 very small northern towns. So when you've not got a lot of people who can, I guess, be implementing this kind of work, and a big amount of area, then yeah, you definitely want to be prioritizing where you're doing this work, and looking at sub-catchments is a great way to start prioritizing that. I guess we should maybe
we're going to run out
of link onto that.
So thinking about implementing MBS, so we know the risks, and now we want to basically reproduce that same MCA approach, but we're going to feed in different metrics and think about each of those MBS and how to tie them into the data that we have. So if we took, for instance, the erosion control and forest planting, it's fairly it's quite intuitive that we're looking for steeper slopes with no trees on them, and especially like closer to watercourses or the conveyance mechanism that we're trying to intercept. Similarly with silt traps, leaky barriers, we'd be looking for shallow overland flow paths or concentrated flow paths. The riparian planting and buffer zones, next to streams and unshaded streams, we're going to see multiple benefits coming through that. Floodplain reconnection. So poor hydraulic performance, that's where we may see a lot of that scour and down cutting of beds, and think maybe we want to slow the water, lift it onto the floodplain and take some of the energy out of it. We ranked all of these in a 1 to 5 ranking, just so we can normalize it and produce a prioritized spatial mapping, essentially.
I can go through this next one. So yeah, this next slide showing our potential case study site in the upper catchment. This site's about 200 hectares, as shown on the left, and if you look back at some of the wider catchment and the sub-catchment combined risk maps, it was one of the sub-catchments that showed up as being a high-risk sub-catchment. And another reason why we chose this area is because downstream, so at kind of the northeast corner, you can see Matawai-Maramaku Road running past. So that was another one of our road flooding locations, so one that cuts the community off quite regularly, and we have a school and a marae just around the corner. And even just looking at the aerial maps, we could see it was kind of a degraded sub-catchment. We had those eroding hill country and gullies, and then disconnected floodplains. So we met with the landowners here who are linked in with Ngāti Hini, the local hapu, and this is just one block of the kind of wider farm. But they were quite interested in restoration work on their farm because they were definitely seeing the impacts of the kind of land use transition over the last few decades.
Yeah, skip on to the next one, just looking a little bit of the hydrology within the case study side. So again, we've got the barren hills and the concentrated flow paths, which basically sit over where we're seeing these active erosion features. It comes off the hills pretty quick, hits the floodplain and straight into these straight ditches. So it's getting conveyed at quite high energy towards the wetland downstream and towards the road as well. So we are seeing that poor hydraulic performance, and it's backing up, and there's quite often flooding over the road and poor hydraulic conditions for fish and well, essentially tuna, eels.
That was something that the local farmer had mentioned, is that over time, I think it was this year, he was saying the tuna migration was 2 months later than expected. So there's a bit of concern from the locals just around the environment as well, which is why it was also a great case study site, because there was a lot of interest in what could be done.
Looking at the risk scape, so as you would expect, those steep slopes, we're getting a lot of high risk on those, and along those straight ditches, again, you're seeing that in-stream erosion, the down cutting of it. In terms of nutrients and pathogens, it's a grazed landscape, so it's really on that connectivity to the watercourse. When thinking about the combined risks, it's just replicating what I've said. It's all in the conveyance and the connection to water.
Hydrologically connected, yeah.
So moving on to the outputs from the analysis, I'm sure this is the one you've all been waiting for.
Waiting patiently for 50 minutes.
Yeah, so what we've got are essentially this is just showing priority class 4, but we have mapped out where we need to get planting. Really, it's those steeper gullies. You're seeing a lot of those. Essentially, we need to get that native forest back up into the catchment, control the eroding hills, and also during that interim period, as I mentioned earlier, that MBS, in my mind, it's a transition step. So in the interim, we'd be thinking about intercepting the silt. So we've got the silt traps, which are sized according to the contributing catchment.
Shown as the white dots. The white dots.
Yeah. In my next slide, I'll talk a little bit more about the silt traps themselves. And then we've got the riparian planting. It's not suitable everywhere. So yeah, the way that the mapping works is essentially just pinning down to the most suitable. It avoids any mention of 8-meter buffer strips or our own imposed metrics, and it just looks at purely like physical or
risk and then intervention.
Yeah,
risk, I suppose.
The mapping clearly shows that on the downstream end, we could reconnect and improve the wetland features, create some storage down there and some better hydraulics, which I'll show later will improve the flood situation.
Yeah. This was just like a really powerful output for, I guess, not only myself to see like the scale of change that's required to see these kind of benefits. That was always one of the questions from the beginning is, what do we need to do with how much nature-based solutions do we need to implement in order to see these benefits, and being able to see it on a map like this, for visual people. And I think farmers were the same. When we were showing the farmers these maps, I guess in past, you always have these conceptual conversations with landowners and communities around what you can do and what should be done and what best practices. But to actually kind of see it on a map and on your own property as well is just really valuable, because when the farmers looked at this, they said, oh, that's really helpful just to visualize and see, like, yes, these are my high risk areas, these are the interventions, but this is, how much land conversion it will take to start seeing those benefits. And these maps are produced again, like Jonathan was saying, at a 1 meter resolution for the entire hydrological catchment. So the idea is that anybody who owns land in this catchment is able to go on and produce a map for their own property, which can be the basis for starting intervention work or starting to think of what they could be doing on site. And even farm environment plans, those kind of things.
Yes, so it also allows the farmer or project manager to start crossing off areas they don't want to work on. So the next slide is a mock-up hydraulic model of it and the results. So we basically just changed some land use en masse. We've planted up some of the worst riparian zones and the worst slopes, trying not to impose ourselves on the land too much, because we just don't want to force mass transition if it's not needed.
It needs to be targeted.
Yeah, so this farm, the farmer knows where the water's running off, so he's got lots of dams already in there. They're in they need cleaning out, so part of this is improving the storage within them, but also inviting some more sensitive design into it as well. So in terms of the benefits that we're seeing on, well, you see on the chart on the bottom right hand side, there's two 100-year events, a 1-hour event and a 24-hour event. So we're seeing, just from these interventions alone, changing nothing else in the model other than what you're seeing, we're seeing a 15 to 20% drop in peak flows, which is significant. And the cost of it as well, to do all of this intervention using the low cost metric, essentially because the local community has aspirations to form their own environmental teams. And this is the way we believe that it will happen within the catchment. So we think the lower cost estimates are more appropriate. And it's about, is that cost, is there enough benefit to doing the work at that cost? And that's probably a next stage down the line to really get into that conversation. So this is really looking at that improvement to the hydraulics, but the next stage is thinking about whether the farmer's a kaitiaki for tuna, which means he's a guardian of the tuna. He wants them to come up this way. So it's about, are we just designing a pond, a detention basin, or are we designing habitat? So the next slide's building on work by Ian Jowett, who I've recently been in communication with. And it's looking at this habitat suitability index and applying it to a 2D hydraulic model. So the results coming out of it are essentially, I'll talk through what I changed in the landscape first. So you've got your before topography on the top left-hand side. So we've got this, we're aiming to get water essentially off the site as quickly as possible. But in the revised version, we are splitting the flows and nursing it through a nice sculpted wetland feature, and the same on the kind of northwest side as well. So we've got these two pockets that are treating water discretely or individually, and also, as you can see, the habitat mapping. So this is applying. This is within HECRAS essentially. It's applying Ian Jowett's suitability index script and looking at that, the benefits from a hydraulic perspective. So an early iteration of this model that I made worsened everything because I didn't have the arrangement of the wetland feature correct. So I was getting more flooding over the road. I was getting more scour down the channel. But nursing this and trying to really tie hydraulics to habitat, it's a good starting point, because I would probably hand this over to someone like Meg next, who's got the ecology background, and start thinking about like real species enrichment. And this model, I would just caveat and say it's purely hydraulic. It doesn't think about groundwater. It doesn't actually think about sediment, but it does show that with a little bit of thought, we can get some nice habitat, and that is really important in this area. Yeah, we'll move on to the next slide. Oh, this one's a bit of a quick one. So we're going to have to become really quick with this.
Yeah.
So this is in the downstream intertidal zone. So this is using the coastal flood hazard zones and the forward projections for 100 years. And essentially, we've got a little video that shows that in each of these scenarios that we can start working in this class 3 and 4 for basically nature-based interventions in those zones. So as we see over the, we'll see the initial baseline and then moving into 2080, you see this land becoming, it's essentially more at risk from inundation with each step in time and with each increase in sea level rise. So it's providing this intergenerational thought concept. So it's really looking at, yeah, we're okay for now. We've got some pockets that we are heavily defending in the orange zone. It's got coastal embankments, but they are going to become increasingly under pressure, and it's whether it's worth to keep maintaining them, or do we allow that, do we migrate that barrier backwards? Similarly, we can forward plan for the next 100 years and think we're going to start setting this land aside for what could potentially be amazing habitat, and also like really beneficial for those flooding events. Because if we're opening the floodplain up again, then these big river flows that come down, it's not just high tides, but the big flows, it would offer the storage and hopefully the protection for the local towns. Right, hopefully. Have we got another one? So part of the project as well, to be really quick here. So we looked at the monitoring and the funding mechanisms that are needed, and we've developed a feasibility level framework. And the purpose of that is really just, yeah, we can do things, but can we pay for it, and are they working? And part of this, I'm sure a lot of people here would have seen the project life cycle type chart, but yeah, we're going to get to see the biggest return on our investment, rather, or the opportunity costs are better spent at the start of the project through the planning. So like I was sharing with with that small hydraulic model, that things can get worse if we don't design it correctly. And I know that Meg always says shovel ready to me, but in reality, when there is a risk to infrastructure or something else, we really have to be careful about what we're doing. And it's worth spending the money up front rather than trying to fix things that we break later.
So I reached to that. Cool. Yeah, so that's most of our presentation. I guess there might be a few questions that come from it, and happy to go back and look at some slides in a little bit more detail. But yeah, this is just, I guess, an opportunity to also acknowledge the partners that we worked with. I know it's just Jonathan and I giving this presentation, but there have been a lot of hands, a lot of brains behind the project. So yeah, big thanks to, I know Birdie from WaterTech will do a shout out because I think he's on the thing for a lot of hydraulic modeling early on. But then yeah, we also just want to thank Ngāti Hini, all the people from the Kawakawa Catchment and the Taumārere Catchment, Ministry for the Environment, obviously, for the funding. Thank you. Everybody in Northland Regional Council who helped out with the project. We had a lot of discussions with our land management team, because it seemed to be one of those projects that, well, not only land management, but biodiversity, water quality, everybody had an interest in it. And I think that is the idea behind nature-based solutions, is the co-benefits, as Jonathan keeps preaching to me.
Yeah.
It's not just about the flooding, it's about the co-benefits.
Yeah, and I think de-siloing the councils.
De-siloing the councils.
That's
a whole nother conversation.
Anyway.
But yeah, and thanks to Vision as well, obviously, and Jonathan for doing all of the heavy lifting for the project.
Thank you.
And the wonderful analysis. But yeah, I think that's us. Any questions?
Great, thank you so much, guys. There are loads of questions. I think there's about 22 questions, but I'm not sure. There's quite a few people dropping off, just given the time.
Sorry.
We'll go through a couple and then we'll go from there. There were a lot of questions about leaky barriers. won't go into that right now, just but there was actually a previous presentation not long ago, and I put it in the answered column that Will Connolly actually presented on some of that work, and it's saved again on the Resilient Rivers website, so it might be helpful for people who are interested in that space. There are quite a lot of questions about, I guess, the sort of the engagement that you had with those farmers, and that, you know, incredibly valuable to actually bring it right down to that operational level. So one of the questions were really just in terms of the fact that you're asking farmers to take land out of production, and very much that approach of there's multiple benefits to this work, as you were just saying. I guess, how have those been received, and have you sort of got an example of people going forth and doing those actions?
I would just say that the mapping depends on some data that's outdated, so LiDAR from 2019, or it just doesn't know where work has been done, where fences have been put in, where the small plant's been planted. So it's
needs some site validating.
Yeah, so there's lots of great work that's happening. And it's a starting point in the conversation.
It's a great question around kind of taking land out of production, though. I think that was something early on I struggled with a lot, is, you know, how is it feasible to be asking landowners to transition their land when, you know, you might be asking them to transition their highly productive land. So that was part of the benefits of looking at those 8 or 9 different nature-based solutions, because when we're looking at an intervention like hill country erosion, that's something our land management team are already working with on farmers. And when we're talking about hill country up in Northland, it's very much marginal agricultural land. So there are quite a bit of conversations around, not only, I guess, the production of the land, the income coming off of the land, but then also the ongoing income off the land. So for farming, obviously, you get a per hectare rate every year for grazing. Part of it was, we can, there's funds available to maybe install this work, but there was no funding that we could find that was really ongoing return for that lost land. We did kind of deep dive into the ETS scheme and some of the like alternative carbon credit schemes, but didn't go very far with those. I think for the hill country, the ETS scheme is kind of being advised at this stage for those erodible hill zones. But that was kind of part of wanting to do one of these case study sites, as well as to actually look at the economics behind it and say, is it worthwhile for farmers? I mean, I get told all the time by people that, if farmers invest in good land use practices, then it will save them money. And I'm always saying, okay, so where's the numbers? Like, show me the proof of that. Because it's always talked about in concepts. And I don't think there's a lot of good case studies out there, or at least like locally relevant case studies. And so these farmers coming forward to allow us to look at that was really helpful and will be helpful. So the next steps of this is to, I guess we have the plan for the sub-catchment. We know what the rough costings are, and we'll be able to apply for funding for that and set up our monitoring to quantify the benefits after doing the work as well. But it's a good question. I think one of the feedbacks to MFE will be around that, of taking land out of production, and how do we kind of compensate landowners for that, because we can talk around the bigger picture and the benefits to the downstream environment, but you're still asking one landowner to do work that benefits everybody else, and so there needs to be a financial structure that acknowledges that, I suppose.
Great, thank you. And just maybe just one more question for now, and then we'll close it up. So there was a lot of questions too about the risk matrix that you used. So I guess one that's a bit common was around sort of grouping the risks, or what was the threshold for risk, and were they same across all the different categories?
No. It became quite complex because we wanted to pull in all the data that we could have. So some of these are looking at maybe 8 different individual data sets that are weighted individually based on our local conditions.
Right.
So really it's, yeah, like I was saying, there's lots of iteration involved in it. And the thresholds that we used are based on like best practice, really, in terms of whether it's slope or whether it's a concentration of flows or velocities or something that's going to trigger an environmental response. And that's how we dealt with that, by thinking about pulling it right back to the essentially the empirical questions. Yeah, so just back calculating a lot of it was. I don't think that was the best answer, but it's been a we're very much in the insomnia phase of the project now. So
don't know if you can tell, we're a little bit brain dead at this point.
I'll just
we will make ourselves available. You have our email addresses there, and if you do have more technical questions that aren't in the final reports at the end of it, we can certainly start responding to those in time. But it was a very complex and nuanced process of figuring out which of these data sets would have the biggest influence on the final risk or the final MBS. So it's really, yeah, it's really matching what we have with where we wanted to get to. And this process that we've done may not work in a mountainous catchment. We're talking rural Northland. We don't have hills over 600 meters up here, so it's very different.
Yeah, it's a good reminder.
You mentioned to people that they could have a copy of the presentation, and my email box is now full. So it just shows how popular this has been. Like literally 10 minutes over, we've still got 60 odd people on the call. It's you've had like over 20 odd questions come through before we even asked for questions. It's been like such a awesome presentation. Like you've done amazing, both of you, and you've kicked it off really well, presenting all these pilot sessions. You've set the standard for people to live up to now.
Yeah, we're very much looking forward to everybody else's presentation.
Yeah,
I think it's just worth saying that part of the ambition of this as well was to drive not just the conversation around nature-based solutions forward, but the industry in a way as well, that we can start looking at high resolution at large scale and get those tools that we're able to then talk to the landowners with. And it's really just to move nature-based solutions forward.
I think you've done that. You've definitely opened a conversation for that. That's definitely moving forward. And yeah, people love this topic right now. It's definitely top of people's minds. Yeah.
And so just a reminder to everyone who's still online, and I should have said it right at the beginning, is just for those of us that have nature-based solutions that are coming to an end, the funding's coming to an end from MFE, that there's an opportunity to get in touch with Rachel and to present so that we can share our findings. We've done it sort of along the way, but now it's time to show some of the results, and hopefully we'll have an opportunity for someone to pull it all together as well, so that we can read it in a coherent and well thought out manner.
That is the plan. Yep. Still doing my little secrets. So fingers crossed that happens and comes to life. But I will let you all go because I know you've got to get off. But thank you so much. Honestly, you've been amazing. And thanks Ella for emceeing. And thank you so much, Meg and Jonathan. You just seem to know everything by heart. So it wasn't even like having a presentation. It was just like you were speaking, like from, you know what I mean? You're just sharing a story.
We've been having this conversation for
there has been a lot of interest across lots of teams and lots of whether it's farmers or
it's been a great but frustrating project like that, where it's super interesting, but just everything gets pulled into it, and many rabbit holes have been gone down.
But that's
yeah,
that's the beauty of co-benefits, isn't it? Yeah,
it is.
Yeah.
It is beauty and
And you
complexity.
guys, honestly, you can tell the energy together. You're like a really good team. You can see like that, you know, you can tell you've obviously bonded on this project
Glad
together.
that Jonathan still likes me.
Yeah.
I love that though. It's just like, it just seems easy for you guys to deliver this. So, which is great. Yeah, it comes
Appreciate
across
that.
really
Thank you,
well.
Rachel. Thanks
Yeah.
for setting all these up. It wouldn't happen without you for sure.
Oh, believe me, you were the first. It was so easy. The rest will be the tricky ones.
Yeah.
But, honestly, really appreciate it. You've got stacks of questions, but if anyone does want to contact Meg or Jonathan, just reach out and I can pass on their details. There's so many to go through that I don't even know if everyone's still on the call. Probably because we have gone over time. But yeah, really grateful that it went so well. It was a really good presentation. Thank you.
Thanks very
Thank
much.
you.
Yeah, and thanks everybody for the great questions.
Yeah, we'll try and get back to some of them as well.
Yeah.
But please do reach out. It's it's important to us to keep this work
We love
moving.
the conversation.
I love that. I'm definitely going to put your recording on the website as soon as it comes through. But yeah, thank you so much. And
Thanks, Rachel.
there's stacks of, I can send the questions through, but just if you're interested, but I wouldn't. Yeah, I'll send them through to you after if you want to have a look. But you
Awesome.
don't have to
Yeah, that
respond.
sounds great. We'll have a look, and yeah, I'll try send a presentation through. It's kind of, I've even shrunk it in a PDF, but it's still quite big, so I'll get it through to you. So
whatever you can do will help. Yeah, that's awesome. Thank you so much again,
Awesome.
and enjoy the rest of your day, and I'll speak
Thanks.
soon. Thank you.
Good afternoon.
Cheers.
Bye.
Bye.